In this video, we're going to be discussing chemical bonding. In previous videos, we've talked about different atoms and elements. Now we're going to talk about when those atoms come together to make a compound, what happens. So the first type of chemical compound we're going to talk about is ionic bonds or ionic compounds. These are formed when a metal and a non-metal bond and electrons are transferred from the metal to the non-metal. So just a reminder, our metals are on the left side of the periodic table, our non-metals are on the right side. So if sulfur and vanadium got together, we would have a non-metal and a metal. That would be an ionic bond and form an ionic compound. A cation and an anion will form. So a cation is a positively charged ion and an anion is a negatively charged ion. So if the metal loses electrons, it's giving its electrons up, it's going to be positively charged now, it'll be a cation. And the non-metal is gaining that electron or those electrons, so it becomes an anion. So the cation and the anion are attracted to each other. They have opposite charges. One is positive, the cation is positive, the anion is negative, so they are attracted to each other, and this is called an ionic bond. Ionic compounds are crystal structures, and each unit is called a formula unit. So each little piece of that crystal is a formula unit. So here is an example. Sodium and chlorine get together. Sodium is a metal, chlorine is a non-metal. Sodium's valence electron, that one valence electron, is transferred to chlorine. And so then we end up with sodium has lost an electron, so it has a positive charge. Chlorine has gained an electron, so it has a negative charge. And these two atoms are now attracted to each other. They're stuck together in this ionic bond called sodium chloride. And you can see that here. The sodium ion and the chloride ion are attracted to each other. So this is called a formula unit. But this is really just one piece of the whole structure, because each of these, this chlorine ion is then attracted to another sodium ion, which is attracted to another chlorine ion, which is attracted to another sodium ion. So it can go on forever. And so each of these little pieces is called a formula unit, but this whole thing is a crystal structure of an ionic compound. So how can we determine an ionic bond? Well, we use the charges of our different elements to determine what ionic bond will form. So metals are positively charged and non-metals are negatively charged. And the charge is based off of the number of valence electrons. So, for example, everything in group 1, all of these atoms in group 1 have one valence electron. They have one electron on that outermost shell. So when they lose an electron, because these are metals, we're going to ignore hydrogen for a moment. When they lose an electron, they're just going to lose that valence electron. So they would have a positive 1 charge because all of those elements are losing 1 electron. Then we move to our second group. Our second group has 2 electrons. So each of these elements, beryllium, magnesium, calcium, strontium, barium, and radium, will all lose 2 electrons when forming a bond, so it'll have a positive 2 charge. We're going to skip our transition elements until a little bit later because our transition elements, many of them can have multiple charges. The exception is that zinc is always a positive 2 charge. Cadmium is also always a positive 2 charge, and silver is a positive 1 charge. Ag is a positive 1 charge. Other than that, all of these can have multiple different charges, and so we'll talk about that in a little bit. However, they will all be positively charged because they are all metals. So you can ignore these. Actually, you can ignore all of these as well. So all of the ones that I have circled are called multivalent. They have multiple charges. In group 3, boron, aluminum, and gallium all have 3 valence electrons, so they have a positive 3 charge. They will lose 3 valence electrons when they bond. Now in our group 4, we have a combination of non-metals and metals. So our non-metal, our carbon, will all of these elements have 4 valence electrons. So our carbon will gain enough, nonmetals gain enough electrons so that they have a total of 8 electrons. So our carbon would gain 4 electrons, so it would have a -4 charge. Whereas our, and then our lead and our tin are question marks because they are multivalent. Sometimes they have a +2 charge, sometimes they have a +4 charge. So they can get a little bit more complicated. Nitrogen and phosphorus have 5 valence electrons. So they need a total of 8. They're a nonmetal, they're gaining electrons, so they will have a -3 charge. Oxygen, sulfur, and selenium have 6 valence electrons. They need 2 more to get to 8, so they will have a -2 charge. And fluorine, chlorine, bromine, and iodine have 7 valence electrons, so they will have a -1 charge because they need to gain 1 more electron in order to have a total of 8, in order to have a full outer shell, a full valence shell. And our noble gases, for the most part, do not bond. So just an example of this bonding. I'm going to show you how this bonding happens. So aluminum is getting together with oxygen. Aluminum has 3 valence electrons. Oxygen has 6 valence electrons. Aluminum is our metal. Oxygen is our nonmetal. So oxygen needs 2 more valence electrons to have a total of 8. So 2 of these electrons from aluminum will go to oxygen. Now oxygen has a stable, complete outer shell. It has 8 valence electrons. Aluminum still has 1 valence electron, so aluminum needs to get rid of that valence electron, so it has to bond with another oxygen. So now this aluminum doesn't have any more valence electrons, but this oxygen still needs 1 more valence electron. Right now it only has 7. So we have to make another aluminum. So the aluminum will then give another electron to oxygen. So now oxygen has a total of 8, but aluminum still has 2 more electrons left. So we need 1 more oxygen atom, and it will steal these 2 electrons from the aluminum. So now our oxygen, all 3 of our oxygen have 8 electrons in their valence shell. They're all stable, and all the aluminums have no electrons in those valence shell. So aluminum has a +3 charge. Each of these aluminums lost 3 electrons. Oxygen has a -2 charge. Each of those oxygens has gained 2 electrons, and our chemical formula would be Al2O3 because we need 2 aluminum atoms, 1, 2, and 3 oxygen atoms, 1, 2, 3, to create this compound. Ionic compounds can also use polyatomic ions. This chart can be found at the beginning of your packet. So when creating an ionic compound with a polyatomic ion, only take into account the charge of the polyatomic ion. So we are totally ignoring, so for example, with chlorate, this is ClO3 with a -1 charge. It doesn't matter that there's a 3 as a subscript. We're just focusing on the fact that it has a -1 charge. So for example, acetate bonds with magnesium. So acetate is right here. It's C2H3O2 with -1 charge. And magnesium is right here. So it's in our second group. So it's going to have a +2 charge. So we have C2H3O2 -1 with Mg +2. So when these come together, we need our charges to cancel out. So we're going to need 2 acetates for every 1 magnesium. So our chemical formula would be Mg C2H3O2 2, because we need 2 of this whole thing. Notice we put it in parentheses because we are talking about having 2 of this entire ion, not just 2 more oxygens, not just 2 more hydrogens. We're totally having an entire new acetate. We look at that as one whole unit, and we are only concerned with the charge. So another example is ammonium bonds with phosphate. So here is ammonium. Ammonium is special. It is our only polyatomic ion that is a cation that has a positive charge. So notice ammonium has a +1 charge, and phosphate right here, you can see it's PO4 with a 3- charge. So those are our ions. Notice the charges. We have a +1 charge ammonium is +1, and phosphate has a -3. So we need these charges to cancel. So right now we have +1 and -3. So in order for them to equal, I'm going to need to add 2 more, right? So I'm going to need a total of 3 of my ammonium. So I'll have NH4 3. I have 3 of that whole thing, and PO4. So I don't put PO4 in parentheses because I only have 1 of those. So another type of bonding is covalent bonding. It's a bond between 2 nonmetals, and in this case, the atoms are sharing electrons. Electrons are not necessarily equally shared. It depends on the electronegativity of the atoms, as talked about in the previous video. A covalent compound is called a molecule. So here's a chart that shows all the electronegativity values of our atoms. These are our metalloids right here. So our nonmetals are on this side. And so when we're talking about nitrogen bonding with oxygen, hydrogen is also a nonmetal. Fluorine bonding with hydrogen, whatever it is, we can compare the electronegativities. So if oxygen bonds with hydrogen, hydrogen has an electronegativity of 2.1, oxygen has an electronegativity of 3.5. So that means that the electrons are closer to oxygen, but they're still being shared. There's no transfer of electrons like there was in ionic bonding. So here's an example. This is a polar covalent molecule because the electrons are not equally shared. So even though in the diagram it looks like hydrogen and oxygen are sharing electrons, and they are sharing electrons, those electrons are actually slightly closer to oxygen. So oxygen will be slightly negatively charged and hydrogen will be slightly positively charged. But the point here is that the electrons are being shared. That makes a covalent bond. So oxygen still needs 8 on its valence shell because that would be a full second shell. And so it needs to share these electrons with hydrogen because hydrogen is in the first shell. So it only needs 2 total electrons. So in this final picture, they are both stable. They both have complete outer shells. And so just to kind of display this, the differences, it's all on a spectrum. So ionic bonding, there's a complete transfer of electrons. There are full charges, Na+, Cl-, complete charges. Then we have polar covalent bonds, and that's an unequal sharing of electrons between 2 nonmetals. Ionic bonds will only happen between a cation and an anion, so you'll have a metal and a nonmetal. And that's when we have partial charges for polar, and then non-polar covalent, there's totally equal sharing, equal electronegativities, so there is no charge. So this would be like H2, H bonding with H, F2, F bonding with F. When H bonds with C, there's a difference of 0.4. So if there's a difference in electronegativity of 0.4 or less, then it's non-polar. We consider that equal sharing of electrons. So this is a little bit of information on chemical bonding. In the next few videos, we'll be diving a bit deeper.